You're welcome to today's video. So today we'll be looking into ERC-20 token and how to build one from scratch. So what is an ERC-20 token? It is simply a fungible token, and fungible tokens are tokens that are not unique and they are quite distinguishable. So if you have a dollar bill that is mixed in between, 10 notes of dollar bills, so 10 notes of a single dollar bill, and you mix them up together, either one you pick is actually your dollar bill. You get what I'm talking about? It's not like there's a unique bill. It's not as though there's a unique single dollar bill that is actually meant for you. So that is, a fungible token. So it can be exchanged without, I can exchange my single dollar bill with yours because they have the same value. They are basically the same thing. So this is a standard that defines, the behavior of an ERC-20 token and how the EVM is going to understand that you're actually working with an ERC-20 token. So it's expected to have a function name that tells us the name of our token, the symbol, the decimals, like ether is it's in decimals, the total supply, that is the total number of tokens in circulation, the balance of a particular owner, to transfer from one person to another. And then transfer from is a third party being able to spend your tokens on your behalf, such as an escrow. So this approve is what approves, it is what you use to authorize the number of tokens that a particular third party can spend on your behalf. And then we have the allowance. So the allowance is the number of tokens that a third party can spend on your behalf. And then we have the transfer events and the approval event. So the transfer event is being emitted whenever the transfer from function is executed, and then there is the approval event that is to be emitted whenever the approve function is being called. So without further ado, let's get started. So I will initialize my truffle project. So we have our test folder, our contract folder, and our migrations folder. So in our contract folder, we will create our ERC-20. So this is our truffle config that tells our truffle program how to behave. So in it, we have the version to be defined. You can set the version, whatever version it is that you want to work with, you can set it here. But this is the version that I will be working with. Okay, so let's. So we want to create the contract name. Now, so we said earlier that it should have a name, it should have a symbol, and it should have a total supply. So let's set the name of our token. And so to set the name of our token, we will need a particular variable that holds the name of our token, and then the function that returns the name of our token. So, but to do that, I would like to create a constructor. So within this constructor, I would define everything that's I would define every information that's the token needs, such as the name, the decimals, and the symbol. So let's set the name and our symbol. Good. So I'll create a function that returns the name, and I'll make the function to be external. String memory. So to follow the same pattern as the name, good. Now let's write a test. And now let's test the name and the symbol of our token. So to do that, before I continue with the test, I would like to install two libraries basically. So before the test, we need to have access to our smart contract. So Truffle has given us like a method to be able to have access to our smart contract, and to do that, so we have the artifacts. So then the contract name, Good. So then this is how we can proceed with writing tests for our smart contracts. So here you can specify the name of the test you want to write. So let's see your library. So good, it's installed. So we can proceed with testing. So I need this. Yeah, I need the instance of this ERC-20 to be global because I'll be using it across all my test cases. So let me define. So before each test case, deploy an instance of this. So this is how we can deploy a new one. So but we need to take in the name and the symbol. So let me define a name here. What name can I give it? So the name of my token is GXP. The symbol of my token symbol is GXPT. Let me just say GXP token. Let me just say GXPT. So within this new, I will pass my constructor value there. Symbol. So let's test so let's test that it's deployed successful. That is, we have a contract name. So we have a contract address. So I would like to test that my contract address is not empty. So let's run the test. Oops. Okay, so we have to specify the location of the string, of our string name and string symbol. So it has to be memory. So good. Then it says it's undefined. So that's test case 20. Oh, I'll wait. It returned the promise. Good. So our test has passed, so our contract now has an address. Then let's test the name of our smart contracts. Name of symbol. The symbol. So because it's going to return the promise. So let's con. So the returned name is accurate. So the second argument is just a means for us to be able to debug accurately, and I will show us the reason for that. The symbol. And I would like to console.log the returned name, and as well console.log the returned symbol. So you see, so it actually returned the name of a token as GXP token and GXPT as the symbol, and the test passed. Like the name returned from our smart contract matches the name we actually fed to the smart contract. That is the name we gave to our ERC-20 token. So so I want to show us the reason for the second argument. So let me say that it should be equal to name. Of course, the test will pass, but this will give us a pointer to this is going to act like a pointer to where the failure comes from. So as you can see, the returned name is accurate. Expected value is name, but the actual value is GXP token. So this here has given me a pointer to where the failure could actually have come from, which is here. So good. Good. So now we have the name of our symbol. So we have the name of our token and the symbol of our token. So what about the decimal? Then so just like Ethereum, I will be working with the decimal of 18. So what we do, because my decimal is 18, that will be 10 raised to 10 raised to the power of 18. You get what I mean? So by the time we will be minting a new token, so this token will be multiplied by the decimals. So let's create a function that returns the decimal. So we will return decimal. So yeah, let's just describe name, symbol, and decimal, right? So we want to test the decimal. It should return the decimal of the token. I will leave the decimal as 18 actually. So what I would like to do is, because the smart contrast is going to return a big number, like type of big number, so I would convert it to number and say it should be equal to 18. Then the returned decimal is accurate. So let's run the test. Good. So our test passed, right? Now that our test has passed, let's go ahead and start minting, like, start to mint and then we transfer. But I will not create a function that mints, neither will I create a function that burns. I just want to focus on these functions. So I'm going to create, I'm going to mint tokens right from the constructor, and I'll mint them into the wallet of the deployer, and then the deployer can start to transfer the tokens just to keep things simple. So what am I going to do is that, so we need to create total supply. And then I want to create a total supply of 1,000 tokens. But this time around, I need to multiply it by, I need to ensure that it is of decimal 18. So, the way we have so I'm going to like represent this token in that kind of units. 10 to the power of 18. So this is our total supply. So then I can create a function that returns the total supply. So right now we've created the name, the symbol, the decimals, and the total supply. It should be decimals. Yes, decimals. Decimals. So, but before I test for the total supply, I would just like to mint into the balance, into the wallet of the deployer or the person creating this contract. So, to do that, we need to have a way by which we can track the balances. We can track the balances of people receiving tokens. So to do that, we are going to use the map. So because we want to create the balance, we want to like track the balances. So we'll be mapping address to, to their balance, that is to the amount of tokens that they are actually holding. But we are going to make it private because we don't want it to be public and then anybody can just change the value anyhow. No. So it's a good practice to make these variables private, you understand, and then create a public or an external function that returns those private variables. So balance of. So now that I've created an internal function, sorry, a private function, that tracks the balance. So let me update the balance of the deployer. So its balance will be equal to the total supply. So what have we just done? We've just assigned, the total supply to the deployer. Then it can begin to distribute the tokens to anyone as it likes. So I will create a function that returns the balances of people. And why is that? So this balance of function, it takes the address of the owner and then it returns the balance, you see? So we are going to take it a step at a time. Balance of address of owner. View returns. What are we returning? Balance. So what we are going to do is we are going to return, balance of owner. It's as simple as that. So now let's test total supply and the balance of of the owner. So to do that, let's just say decimal and total supply. So it should return the total supply of the token. So the return total supply is accurate. So now we want to test for the total supply. So how can we go ahead to test for the total supply? So to do that, I'm going to create an helper file here. Let me create a folder. So in this file, what I want to do is that I want to create functions that I will be needing. And one of the functions that I'll be needing is I need a function that can help me to format, values into, way, like, it can break it down to the value that the smart contract is going to understand, because the smart contract is dealing with values in this particular, decimal. So I want to create a function that does that for my, for my test as well. So what I'll do is now, because we are dealing with truffle, so we actually have access to the Web3, like to the Web3 library. So what we are going to do is that I'm going to return, and then we have the utils method, and then because we are dealing with big number and they want to send a big number to the smart contract. So what we are going to do is we are going to parse way to the smart contracts. To string, and then this ether. So right. Good. So now let's go and import this. So we want to test that our total supply equals tokens, of 1,000, right? But this token of 1,000 is in big number, it's a big number. So I'm going to convert it to type number. And while I do that, I would like to, console.log total supply. That's a string. So, undefined, the decimals, it should be the decimals. So it just said that cannot read properties of undefined big number. So let me check what is wrong. Properties. Good. So it's just our test just passed, that our total supply is equal to, our tokens. So that means that our function accurately formatted, our these 1,000 tokens into way. So now we'll be testing for the balance. Let's test the balance of the deployer. So to do that, we need to return the balance. Return the balance. So I will just describe a test case for the balance. Now, for us to actually have access to the player's address, so in Truffle, you can actually specify the address here, because Truffle gives us access to some addresses by default, and we can't see them. But if you're working with Ganache, let me show you Ganache. So if you're working with Ganache, you actually have access to about 10 addresses here. You have access to 10 addresses, and with that you can have access to the index of the address. You can name it address 1. So with this address 1, it will give you access to the first address here. Then if you specify address 2 after address 1, so it will give you access to the second one, and then you can do that for the rest. So I would like to name the address as the deployer's address. So let me console.log the balance first. Then balance of is not defined. Okay. Oh, my apologies. Should be ERC-20. That's good. So it returned the address of the balance, and we can see that, it returns the balance of the deployer, and we can see that it is the same with the total supply. So let me just write a test for this. So this function will return a big number. So I would like to convert it to number. And then our test passed. So what is the next thing to do on our list? So now that we can get the balance of a particular order, so now we want to transfer, right? So for us to transfer, there's some basic things that we need to know about transferring tokens from one person to another. So for you to transfer, of course, you need to have enough tokens in your reserve. You need to the recipient should not be address 0. So you can make it to address 0 whenever you want to burn your tokens, and then you can transfer. And then after you transfer, your balance gets reduced, your recipient's balance gets incremented, and then an event should be fired. So we have 2 events here. This is the transfer event and the approval event. So this transfer event should be emitted whenever the transfer function is called or the transfer from function is called. While this approval event is going to be called whenever this approve function is being called. So let's get to it. Now we want to transfer. As we transfer, we need to transfer to, we need a parameter to, and then value. So this function assumes that the sender, that is msg.sender, is the person releasing the token from their own reserve. So value. So what are we to return? We are to return a boolean, which is success. So success can be true, success can be false. So we return true when everything goes on well. Now, so like I said earlier, you need to have, so the person sending this token should have enough tokens in their reserve. So what do we want to do? We use the require. So we want to ensure that the balance so what we are doing with this require statement is that this is the first the first parameter is the condition, while the second one is going to be, should in case the condition is not met, met, so it's going to revert with this particular reason. So this is going to be the reason for the revert, and that is insufficient token. And then so let me create a test. Describe balance. So describe transfer. So to describe transfer, we want to test for the success cases, and then the failed cases. Now, so I want to test for failed cases, right? So first of all, I want to test that a transfer is going to fail when the person has an insufficient balance. So to do this, let me name the second address as let me just name it as from, or you just name random person one, and let's just leave it as that for now. So now we want to test that this transfer is going to fail. So let's see how it's going to revert, right? Let's see how it's going to revert. So random one, and we want to send tokens. Let's say I want to send one token. So let's see when we run this test. Oh no, should revert due to insufficient token. I did not specify who is calling this function. So so let me know this. Whenever you are calling a function from a smart contract, by default, if you don't specify the from, by default this is going to be the sender, the deployer. But when we deployed our token, our deployer was issued the total supply, right? So that was why this particular transfer was successful, because by default the deployer called this transfer function. So I want the one to call this function. He doesn't have any token yet, so let's say it sends to deployer. So let's see what happens. Good. The VM exception, this error reverse reasons. So it's reversed with insufficient token, right? Insufficient token. So a very good practice when it comes to testing is that it is good to test exactly what is wrong. I mean, you need to be specific with the exact reason. Like that is, you need to be specific with what exactly are you testing. So let's say that. So how am I going to do that? I'm going to create a value called reverts, and this one is going to be called and what is it going to imply? It is going to imply this, right? So I would like to test exactly what is wrong, and what am I going to do? So with this rejected with, we can specify exactly what it is I want to test, right? So let me import this reverts. That's insufficient token. So let's run our test. Good. So we've just tested that this particular, function call, this contract call should fail due to this reason. So let me say that I am testing for insufficient allowance, which is a wrong reason that I'm testing against. Then the test should fail. Can you see? So I was expecting it to fail due to insufficient allowance, but it actually failed, due to insufficient token. So this is a very good way to test. You understand? So, so this is a revert reason. So over time, as we had more, revert reasons in our smart contract, we will update we always update these objects. So let's proceed. Also, our recipient should not be of address 0, right? Address 0 is like it can also be called ether address or a null address, right? So your reverse reason can be anything, so it should not be address 0. So but I need to get the address 0, so let me just create a random, don't worry, this is just I just need to don't worry, I just want to get this value in my I need this particular value so I can use it to test. So let me um good. So I needed this address 0. So I don't need it anymore. I don't need it anymore. So let's test that it's going to revert if the recipient is address 0. So we want to send to random 1. We want to send one of our tokens. Oh, sorry, not to random 1, to ETH address. Now, what exactly we want to test against this? So I'm going to name this address 0. Good. So let's test. Good. Should revert due to address 0. So our test passed. Now let's release the tokens. So what we're going to do is we're going to say the balance of value so what have we just done? We've just we've just reduced the balance of the sender, and then we've just incremented the balance of the recipient. So let's test for success. I would like to use test it in the before each. So now, so we are sending 10 tokens. So let's test the balances. I keep missing this thing. So we should have 990 tokens. So let's test the recipient's balance. So let's test. Good. Our test passed. So let me just console.log this balance of the recipients for clarity purpose. What's wrong? I can't find the balance. Oh yeah, this is it. So it's actually it's you can see it's lesser than this, but let me let's spend this. Oh no. It's not going to, that's not going to do. So we've just received like 10 tokens, and this is the equivalent of it in a way. You get what I mean? So good. Now, so an important thing that we need to do is that we need to fire a transfer event, this event. So this event should be emitted whenever so it needs to be emitted whenever a transfer, is being done. So let's define the event. So we have indexed from and indexed to. So the reason why we actually use the index is because by the time we are trying to, filter these transfer logs, we can easily um we can easily filter based on these addresses. You get what I mean? So this index actually makes it easy to filter based on these addresses, and then to filter based on the recipient. So that's one of the reasons why we use the index keyword. So let's emit. So if in this in this case, we are transferring with the from, and then the to, and then the value. So let's test the event that is being emitted. So here I describe balance. Here I'm going to describe events. So to do that, let me console.log our transfer. So you're going to see how we can get our events. Good. So as you can see, this is our transfer object. This is our transaction, and within this this object in itself, we have the transaction. After the transaction, this TX, we have the receipts. So all of these is within this, receipts, and then after that we have the logs, and you can see that this log is followed by an array. You understand? So within these logs, we can get the event name. So how are we going to do that? So we're going to do transfer.logs. So this is what we're doing. We're doing transfer, then .logs, then this logs, this because it's an array, so this is automatically index 0. Index 0 dot. So within this index 0, we have the events, right? Oh, no, I don't want to clear out the mistake. So we have this. So within this index 0, we have the event name, which is called transfer. So now that I have actually gotten the event name, I also want to test like this data, the from, the to, the value. And where is that from? So that is, we're going to get that from these args, right? So let me console.log the args. So let's test again. Good. So I just console.log the args, and within the args, you can see the from, the to, and the value, which is a big number. So we can test the data that's, that is being emitted from the transfer event. So obviously this test passed this, the event name. So let's test the transfer, the hags, the data that has been emitted. Now if you can see that the parameter name here is underscore from, underscore to, and underscore value, and it follows the same pattern here: underscore value, underscore to, underscore from. So we're saying the from because the deployer, was one that made the transfer. So I'll use the same pattern for the to and then the value. I know we know that our to was the random one address, but the return value for the value was a big number. So I'm going to convert it to number. And how much was being transferred? Just 10 tokens. Now let's test. The value emitted, value transferred expected, but got, oh, I was supposed to convert this to number. Good. So we have successfully created the transfer function. So right now, our ERC-20 token has, name, symbol, decimal, total supply, balance of, transfer. And then we are left with 3 more functions, and that is the transfer from, and then the approve. But before we can use this transfer from, we need this approve and the allowance. And the reason is because this transfer from enables, a third party, such as an escrow, to be able to send a transaction on your behalf. So in that case, let's initialize another address called escrow. And we want to describe transfer from. But before we can actually describe transfer from, let's create the approve function. So describe approver and allowance. So we are going to deal with these 2 functions, and then once we're done with these 2 functions, we are going to deal with this transfer from. So for us to approve, we need to identify the address of the third party that we are approving. So in our own case, we want to approve an escrow, right? So what do we want? So what are the parameters? The address, sorry, the approve, the address of the spender. So let's do that. So this spender is a person, or is the entity that will be gaining the approval, such as an escrow. And then we have the amount that will be approved. So for example, you can have 1,000 tokens and approve an escrow just 10 tokens. So that means that the escrow will not be able to send more than 10 tokens. You understand? Only the amounts approved is what they will be able to spend on your behalf. Yes, that reminds me, in this transfer, we are supposed to return bold. So we return true. So we are done with that. So public returns both sources. But I just chose to use external. You can use public. So what are we trying to do? So first of all, let's just require that the spender is not an address 0. Oh, should not be. Let me update my, no, let me update it so my test will not fail. And then now we are just, so the next thing is to approve the spender, right? And then we need to like assign some values, like some value to the spender. So we are going to need a variable called allowance. You understand? Allowance. So how do we want to go about this? So we want to map the address of the person making the approval to, the address of the entity that has been approved and the amounts they are being approved. So don't get confused. This address is the address of the person that is making the approval. In our case, this deployer will be approving escrow to send the token on their behalf to this random one. So this address represents the token holder. This address represents the spender to be approved. This amount, this U256 represents the amount that will be approved. You understand? So it's called allowance. And then should be mapping. Yeah, mapping. So now we're going to say the allowance of the message the sender So if you notice, we are not incrementing it, right? So because the value because this value should overwrite the existing allowance. So let's say that an allowance of, let's say, 10 tokens has been made initially and you are approving 20. So the total allowance is not going to be 30. The total allowance is going to be 20 because the 20 should overwrite the existing number of allowance. So that's how this is going to work. So, and then once this is done, I need to emit the approve event. So, but to do that, I need to create the event called, what's the event name again? Approval. So the owner, that is the person that owns the token, and then the spender, and then the value. So let me just copy this, paste it here. The owner, spender, and the value. So I will emit it right here. Right, so let's test the approval. And then, okay, for now, just the approval. So don't worry, I won't be testing this failed case. It follows the same pattern as we did in a transfer. So I'm just going to make the successful approval. ERC-20, the approve. So who are we approving? We are approving escrow. And how many tokens are we approving? We are approving 20 tokens. Who is making this approval? The deployer. Good. So let's describe the event. And we also describe allowance. Good. So just like, it's going to follow the same pattern that we did for the transfer, right? So should defense name and data. So and then I would like to test the data emitted. The spender in this case is a escrow, and then the value we convert it to number. So let's run our test. Oh, something wrong. Yeah. So our test passed. We've just tested the approve. So one thing, because we have to return bool success, so true. Now we have successfully made an approval, but what does this imply? So let's create a function that returns the allowance. So the remaining allowance, that is want to return, we want to return, that is so in our case we approved 20 tokens. So let's assume that at a particular point the escrow spent 10 tokens. So it is the job of this allowance function to let us know how much um how much is left for escrow to spend. So let's say escrow has spent 10 tokens and then we've approved 20. We know that escrow has 10 tokens left to spend. So, and this allowance function is one responsible for that. So what are the parameters? So it needs the address of the owner and the address of the spender. Good. It's as simple as that. So let's test the allowance function here, because of course the escrow has not spent any tokens, so obviously the allowance should be 20. So the owner in our case is the deployer, and the spender in our case is the escrow. So we expect that allowance good. Now we are almost done creating our ERC-20 token. So now let's come to this transfer from. So I would like to create my transfer from. I just want to like make it, accordingly. So I would like to create it like on. It doesn't imply anything, but I don't want to make it accordingly. So after transfer, we have the transfer from here. No. So we are going to specify the address of, the where we're making the transfer from. That is the originating address, and then the recipient address, and then the value to be sent. And what is our return type? It's just the same as transfer. Good. So just like transfer, I want to ensure that it's not address 0, but each time around. So what are the important conditions? This address from should have enough balance. So let's copy this. But this time it's not the MSG.sender is the spender, that is like an escrow. But the transfer is going to be made from the balance of from. So we want to ensure that from should have sufficient balance. You get what I'm talking about? So sufficient balance. Also, we want to make sure that the recipient address is not address 0. And also, we need to also ensure that this spender can only spend within the limits of the allowance assigned to them. So that means that so what does this third condition implies? So this third condition implies that this spender, you understand, should have enough allowance to be able to like that is because whatever it is that they'll be sending is going to be from the allowance. So and then we are going to do this. But this time because we are reducing it from the from balance, right? And then we are giving it to this 2. So once that is done, we also need to reduce the number of allowance. So let's say that 10 tokens, let's say we've assigned 20, we've approved 20 to this particular spender, and then the spender sends 10. Of course, the remaining allowance should be 10 balance, right? So we need to update the allowance. Good. So we are good to go. And then we also need to emit the transfer events. And this time around, MSG.sender is not the owner. It is from, then to, then the value, then we return true. Good. So unlike when I was making this transfer function, I was like writing the text alongside it. But now that we've done for transfer from, so let's test the transfer from. Let's make the test here. Then we describe failure. So what are the things I want to test? I want to test that, we want to test insufficient token. We want to test for address 0. I also want to test for insufficient allowance. So let me go and update my test case with this. Good. So we want to send from, but the deployer definitely has tokens in its balance. So let's send from random 1 to send to deployer, and then he wants to send 10 tokens. So this case, the spender, which is our escrow, you understand, is they want to call this transfer from function, but they should revert. So as you want the test, token is not defined. Tokens. Good. So that's the first test. Let's test address 0. So this time, one is, because we need this first test to pass, for this one for us to get to this point, so we need to use the address that has sufficient tokens. Good. Then the last test for revert should revert due to insufficient allowance. Good. So we expect that the transfer from should fail if there is an insufficient allowance, right? So, and you need to know that the allowance we did here does not, it's just within the scope of this particular, it's within the scope of this test, so it doesn't cover this test, you understand? So that's why, because the allowance was done within this particular test case, so it doesn't go beyond this block of text. So now for the success, so before our escrow can spend the token on our behalf, we need to approve the escrow. So the deployer will do that. ERC-20 that. So we approve the escrow, and then the escrow should be, given an allowance of 20. From the deployer. So the deployer has just approved. So now that she has approved, let's make transfer. Let's do it. Transfer from deployer to random one, tokens of 10. Tokens of 10, and then it's going to be from escrow. So let's describe. So I would like to describe the events. So we want to test this. So just like we did for the transfer, let me just copy this. And into this. So the event name should be transfer. The from is from the deployer. And then the recipient is the random one. And the number of tokens sent is this. So let's run the test. Okay, something wrong. Transfer is not defined. So should be transfer from. Okay, logs 7. Oh, what am I misunderstanding? Good. So we've just, tested that the transfer was successful, but let's test balance and the remaining allowance. So so we actually tested balance earlier within this transfer function. So I will also use, it's just the same number of tokens that we sent. The only difference is that this transfer was made by the deployer himself, but then this particular transfer was made by the escrow. So no, this one is not updates the from balance and updates the recipient's balance. Good. Yes, the escrow was a spender, sender actually. So let's test the balance. Good. Now we want to test the allowance. So we've already written a function for the allowance earlier. So let's copy this. So should return the correct allowance. So now we've just, spent 10 tokens. Like the escrow has just spent 10 tokens. The escrow was approved 20, but the escrow just spent 10. So that means that the escrow should have 10 allowance left. So 10 allowance. So let's return. Let's run the test. Good. So right now we've just successfully created an ERC-20 token. So how can you make this smart contract better? You can create a function to mint, that is, to increase the total supply. You can create a function to burn. You can create an internal transfer function, because you can see with this repetition here, like, will this thing, or this particular block of code was being repeated, insufficient here, and then we can just create an internal function that's so we don't repeat ourselves again. So what I would try to do now is that I would try to, so that is it for this, like right now. So let me deploy the smart contracts, to my local testnet, which is Ganache, and then I will import my token. I'm going to import this token, my MetaMask, and then I'm going to transfer it, between my MetaMask, between my addresses. So what I'm going to do right here is so that's in my migrations file. So I want to create my migrations. So just like we did within our test scripts, this. So I'm going to copy this. Then I'm going to do model. Then my constructor here, is what's my constructor? The name and then the symbol. So I would like to, so what's the name? GXP token, GXPT. So because I want to deploy to Ganache, so in my truffle config, so oh, good. So we've just deployed to Ganache. So this, let me check my logs. The contract address is 0xp4. Yes, so this is the contract address. So right now what I'm going to do is I'm going to import it in my MetaMask wallets. here. So what am I going to do? Because this is my deployer's address. Where's my deployer's address? Deployer's address, where are you? Accounts, this one, which is this. So I need to import this private key in my MetaMask. No, good. So I need to import my tokens. So what's my contract address? So as you can see, by default, the token symbol is GXPT, and then the decimal is 18. That's it, we have 1000 GXPT. Good. So let me send, this GXPT to one of my accounts here. Let me use these accounts. Let me copy this accounts here. So I want to send GXPT to this account, and then I want to send 30 GXPT. Good. So we've just sent 30 G. You can see the balance has reduced. So let me go to this address, and then let me import the token. Good. You can see. So I have 30 GXPT in my wallet. So now, so that's how we, we've just created an ERC-20 token. We deployed it, and then we wrote test for it. So thank you. So that's it for this video.